Okay, so now we'll go with the Roman number 7. So if you see this function, it's a very interesting function here. Try to find out how many functions are here. What do you think? How many functions we can see here? How many functions? I'll give you a second. Try to think how many functions are here. Let me tell you. There is 1, 2, 3, total 4 functions. We have 4 functions in this case. So which means you need to differentiate 4 times. So let me take this outside function first. But you need to assume this whole thing as a x. Whole thing, all the first. This is the first function. This becomes second function. This root becomes third function. And at last this becomes fourth functions. So that means we have total 4 functions. You need to differentiate 4 times. So let me go with number 1. When you go number 1, assume second, third, fourth function as a x. So that means definitely this will become root x. So you know the special case for root x. What's the differentiation of root x? It is 1 over 2 root x. So therefore, when you differentiate, we have dy by dx is equivalent to 1 over 2 root of x. But in place of x will be second, third, fourth function. So that means here it is 2 plus root of 2 plus root of, oh sorry, let me write this way. Okay, 2 plus root of 2 plus x squared. So that means this number 1 is done. Then let's go with now number 2. Oh, I need a bigger space. Yeah. Now when you go for number 2, now differentiation of this 2, which is a constant, is equivalent to 0. Go with this function. Now when you go with number 2, assume this number 3 and 4 as a x. Now again this will become root x, isn't it? So differentiation of root x is again 1 over 2 root of x. This whole thing is x now. We have 2 plus root of 2 plus x squared. I hope you got it. Now next one, this number 2 is done. Go with number 3. When you go with number 3, assume this number 4 as a x now. Assume this number 4 inside function as a x. Differentiate this one, we have 1 over 2 root of 2 plus x squared. Number 3 also is done. Finally, we are left with now number 4. Differentiate 2 is a constant, x squared is 2x. One of the 2 it will get cancelled. So finally, I say it will be x whole divided by, we have this x, isn't it? So 2 times 2 becomes 4. Let me write this one first. Root of 2 plus x squared. Then we have root of 2 plus root of 2 plus x squared. Then finally this answer we have now here root of 2 plus root of 2 plus root of 2 plus x squared. That's it. Right. I hope you got it. You can have a look here. If you want to put this inside, you can put it, but it will not make any difference. All of them are with the same index square root, but it will not make any difference. Yeah, we can't simplify further, yeah, from this point. So keep it this as a last, okay? Now let's go with the Roman number 8. Here, Roman number 8. As usual, first we'll go with this power, okay? So when you go for power, assume this whole thing as a x. This will become x as to power n. What's the difference of x as to power n? N x raised to n minus 1. Is that a power rule? You remember? What's the differentiation of x raised to power n? X raised to power n is n x raised to n minus 1. So differentiate now, we have divided by dx is equivalent to, that power will come in from n in place of x. Write this whole thing, x plus root of x squared plus 1 raised to n minus 1. This power is done. Get this logic thoroughly. Now go inside. When you go inside, difference of x is 1 plus. Now, when it comes to this, first you need to differentiate root. Then you are going to differentiate inside. First differentiate root. When you differentiate root, as in this one as a x. Logic is same. Differentiate root x is 1 by 2 root of x squared plus 1. Close this bracket, not close this bracket. You need to differentiate inside, which is 2x. I hope you got it. You can watch it here. If you don't get it, watch it again, okay? So then this 2 and 2 will get cancelled. We have n times x plus root of x squared plus 1 raised to power n. Then I can write this one as a x plus root of x squared plus 1 raised to negative 1. And minus 1 I can write this way. We are keeping same base. Please do this LCM. We have now, here it is. Do this LCM. We have x plus root of x squared plus 1. Yes or no? Divided by, please don't forget this one. Now I can write whole divided by. Whole divided by, we have root of x squared plus 1. 2 LCM. This into 1. Here we have x, right? So that we have same power. Is the same power? Right. Same power means here you can cancel or you write minus 1 plus 1 is 0. Any number raised to 0 is equivalent to 1. So we have now final n times x plus root of x squared plus 1 raised to power n divided by root of x squared plus 1. This is the final answer. If you don't believe, you bring this minus 1 down, definitely this one and this one will get cancelled. Otherwise, same base at the power, negative 1 plus 1 is equivalent to 0. Any number raised to 0 is equivalent to 1. That's it. So now, let's go with the last question under question number 1. Now this is under question number 1, this is the last question, number 9. How to go about this one? See, this type of function, please don't go with the u by v method quotient rule here. See, we have here plus, we have here minus, but all the values are same. Always go with the rationalizations. I can directly go with rationalization. How to go about these rationalizations? We have root of x plus 1. Minus means you take here plus root of x minus 1 divided by. You have to divide by same number. Function should not change. If you multiply by 2, you have to divide it by 2, isn't it? Logic. So similarly here also you have to divide by same number. We have x plus 1 plus root of x minus 1. Make sure you put a bracket. If you don't put a bracket, it simply means this will only multiply this function. It does not make sense. Make sure you put always the bracket. So now, definitely, this will become now root of x plus 1 plus root of x minus 1 whole square. Isn't it same thing? This two are set, becomes whole square divided by. Now, if in denominator we have in the form of a minus b, a plus b. What's that? A minus b, a plus b is a square minus b square. You know that formula? So what's a square? Root of x plus 1 whole square minus root of, what's a b value? Root of x minus 1 whole square. Square and root will get cancelled, square and root will get cancelled. So we have now, this is in the form of a plus b whole square. What's a plus b whole square? A plus b whole square is equivalent to a square plus b square plus 2ab. Correct? A square, we have root of x plus 1 whole square plus. You need to have certain base, okay, in order to understand. Otherwise, you won't understand anything here. If you have certain base, then you can understand. A square plus, and then I don't have time to teach all the basic things. You are in class 12 now. A square plus root of b square plus 2ab. 2 root of x plus 1 times root of x minus 1. 2ab, isn't it? And make sure your divider and this equal to is always straight. So we have now x plus 1. Please open the bracket, negative x plus 1, because the root already got cancelled. Definitely plus x minus x will get cancelled. Square root will get cancelled. This also will get cancelled. We which is equivalent to 1x plus 1x becomes 2x plus 1 and minus 1 will get cancel plus 2 times root of. Now these two are same index. If I put, okay, let me write this way. X plus 1 times x minus 1. I am putting on the same root, okay? Divided by 1 plus 1, it becomes 2. So now I can take 2 common outside and cancel. Usually what you people does here it is, you will cancel like 2. No, this is not the correct method, okay? So what we have to do here it is, please take 2 common outside first. Similarly, we have x plus root of, this is in the form of a plus b, a minus b, which is equal to a squared minus b squared, divided by 2. Now you can cancel this 2. Finally, we have y is equivalent to x plus root of x squared minus 1. This is the final answer for y. Now we can differentiate. That implies dy by dx is equivalent to, what's the difference of x? 1 plus, differentiate this function. Again, if you have 2 functions now, by this time you should be thorough. 1 by 2 root of x squared minus 1, differentiate again inside 2x. First differentiate root, again differentiate inside. By this time you should be thorough with this logic. So please do LCM. We have x plus root of x squared minus 1 whole divided by root of x squared minus 1. So this is the final answer. So I have completed question number 1 till Roman number 9. Make sure you complete the homework now, okay?